Modern cloud infrastructure is absolutely massive. We're talking about thousands of servers, complex networks, countless databases, and all sorts of services running simultaneously. Trying to manage all of this by clicking around in a web console. It's not just difficult, it's practically impossible. That's where a tool called Terraform comes in, and it's a complete game changer. In this video, we're going to break down exactly what Terraform is, see how it works under the hood, and explain why it has become a non-negotiable skill for almost every cloud engineer and DevOps professional out there. If you've ever wondered how companies build and manage these huge, reliable systems, you're in the right place. So, what exactly is Terraform? In a nutshell, Terraform is an infrastructure as code tool created by a company called HashiCorp. The core idea is simple but incredibly powerful. Instead of manually clicking buttons in the Azure or Google Cloud dashboards to create servers or databases, engineers write simple, human-readable code to define what they want to build. This code acts as a blueprint for your entire cloud environment. Think of it like a recipe for your infrastructure. You write down all the ingredients, the servers, the networks, the security rules, and Terraform knows exactly how to put it all together. It transforms the messy, manual process of building infrastructure into a clean, automated, and code-driven one. To really appreciate Terraform, you have to understand the chaos it replaced. Before tools like this became popular, setting up cloud environments was a manual nightmare. An engineer would log into a cloud provider's console and start clicking to create resources. This process was slow, incredibly prone to human error, and almost impossible to replicate perfectly every single time. Imagine trying to build two identical environments for testing and production. It was a recipe for disaster. One tiny missed setting in the production environment could lead to a major outage. There was no easy way to track changes, no way to review them, and no way to roll back if something went wrong. Terraform solves these problems by making infrastructure repeatable, predictable, version-controlled, and fully automated. It brings the same discipline and best practices that software developers use for code to the world of infrastructure. So, how does this magic actually work? The Terraform workflow is beautiful in its simplicity and can be broken down into three main steps: write, plan, and apply. First, you write. You define all the components of your infrastructure like virtual machines, storage buckets, and network settings in simple configuration files using a language called HCL, which is designed to be easy for humans to read and write. Next comes the plan step. This is a crucial safety measure. You run the Terraform plan command, and Terraform analyzes your code. It compares what you've defined in your code with what actually exists in your cloud environment. Then, it generates an execution plan, showing you exactly what it will create, what it will modify, and what it will destroy. You get to review every single change before it happens. Finally, if you're happy with the plan, you move to the apply step. You run Terraform apply, give your approval, and Terraform takes over, automatically building or updating your infrastructure to match your code. This transparent three-step process makes infrastructure changes safe, predictable, and auditable. One of Terraform's superpowers is its ability to work with a huge variety of platforms, and it does this through something called providers. A provider is essentially a plugin that teaches Terraform how to interact with a specific API. There are official providers for all the major cloud players like AWS, Microsoft Azure, and Google Cloud. But it doesn't stop there. There are providers for Oracle Cloud, for Kubernetes, for managing your GitHub repositories, for Datadog, and hundreds more. This means you can use the exact same tool and workflow to manage resources across many different platforms. If your company uses AWS for its main applications, Google Cloud for its data analytics, and GitHub for its source code, you don't need three different tools. You can manage it all with Terraform, giving you a single, unified way to handle your entire multi-cloud and multi-service infrastructure. It's this flexibility that makes it so incredibly powerful in the real world. Now, you might be wondering, How does Terraform keep track of everything it builds? How does it know what already exists so it doesn't try to create it again? The secret is a special file called the state file. The state file is Terraform's memory. It's a JSON file that maps the resources you've defined in your code to the real-world resources that have been created in your cloud account. Every time you run Terraform apply, Terraform updates this state file to reflect the new reality. When you run Terraform plan, it consults the state file to understand the current state of your infrastructure before figuring out what changes are needed. This state file is absolutely critical for Terraform's operation. It's what allows Terraform to manage the lifecycle of your infrastructure, track dependencies between resources, and perform complex updates safely. Without state, the automation and intelligence that make Terraform so valuable just wouldn't be possible. So, why do companies, from brand new startups to massive global enterprises, absolutely love Terraform? The benefits are crystal clear. First, it enables faster deployments. Developers and operations teams can spin up entire new environments for development, testing, or production in minutes, not days or weeks. Second, it drastically reduces errors. By codifying infrastructure, you eliminate the manual mistakes that cause outages. The plan step acts as a safety net, ensuring no unexpected changes slip through. Third, it brings version control to your infrastructure. Just like application code, your Terraform code can be stored in Git, allowing you to see who changed what, when, and why. This also means you can easily roll back to a previous, known good version if a change causes problems. It also makes disaster recovery much simpler. If an entire region goes down, you can use your Terraform code to rebuild your whole environment from scratch somewhere else. Ultimately, it ensures you have consistent, identical environments every single time. It's a foundational tool for modern, agile IT. A common question is, don't the cloud providers already have their own tools for this? And yes, they do. AWS has CloudFormation, Azure has ARM templates, and Google Cloud has Deployment Manager. These are powerful tools, but they have one major limitation. They lock you into a single provider. If you write all your infrastructure code in CloudFormation, you're tied to AWS. Terraform, on the other hand, offers something truly unique: cloud independence. It provides a consistent, vendor-agnostic workflow. The core skills you learn writing HCL, running plan, and apply. Managing states are the same whether you're deploying to AWS, Azure, Google Cloud, or all three at once. This abstraction layer is a huge strategic advantage for companies, allowing them to choose the best cloud for the job without being locked in. And it makes engineers with Terraform skills incredibly valuable because they can operate anywhere. To wrap things up, Terraform has fundamentally changed how we build and manage modern infrastructure. It took the chaotic manual process of clicking in a web console and transformed it into a disciplined, automated, and code-driven practice. It allows us to treat our cloud environments with the same rigor and best practices that we apply to our software. In today's tech landscape, if you're looking to work in cloud computing, DevOps, or site reliability engineering, knowing Terraform is no longer just a nice-to-have skill on your resume. It's an absolute essential. It's the language of the modern cloud. Thanks so much for watching. If you found this video helpful, please hit that like button and be sure to subscribe for more content on cloud and DevOps technologies. See you in the next one.